All right. Um, Hello, everyone. Thank you very much for joining to this to our webinar. Today, we're going to speak with you about predictive AI without data limits. Again, I would like to thank everyone that joined us today and spend your time with us. My name is Oren. I'm from Screen Marketing Team. With us, who's going to present today is Gil Cohen, who is our talented technical product manager. Um, and we want to start in a few minutes. I just want to give the opportunity to some other people that didn't have the time to join to try to join the webinar as well. So we'll wait a couple of more minutes. I would just like to let you know that this webinar is recorded and is going to be available later on through our YouTube channel and website. We will have some time for Q&As later on at the end of Gil's presentations. So if you have any question, please use the Q&A feature at the bottom of the screen. Write your question, and Gil will be happy to answer it at the end of the webinar. So one more minute, and we're going to begin. Uh, just let some other people the opportunity to join. All right. So, Gil, the floor is yours.
Thank you, Oren. Thanks for having me. And thanks everyone for coming and spend your time with us. Okay, so before I introduce myself, my company, and our products, first let's talk about what we're going to talk about today. So in this talk, we're going to talk about predictive AI without data limits. That's the headline. Basically, we're helping organizations use predictive AI and ML at scale with its limitations. As you know, this is a very lengthy process that requires a lot of efforts and a lot of investment, and we aim to shorten the cycle and achieve much better results with higher accuracy that will allow a lot more models to reach production rather than just stay on the development floor. And that's what we're going to address today. Yeah, so start by introducing myself. Hi, I'm Gil. It's actually my 7th year at SQream. As you see my career path down there, I started as a hardware engineer, and then I started developing at SQream, our compiler, our proprietary compiler. Then I progressed to some managerial positions, leading teams and groups, and took a short break and worked for Vast Data, help building their data platform. And about a year ago, I returned to SQream as a product manager. So I'll tell myself that I'm married to Inbal, father of 2 toddlers. Maybe that's why you can see the black bags beneath my eyes. I'm passionate about basketball, snowboarding, and obviously databases, AI analytics. Okay, so enough about me. Let's talk a bit about SQream. So basically, SQream is a data processing acceleration platforms. We utilize GPU to accelerate predictive AI and analytics over the GPU. So basically, I'm going to touch a bit about that later. We're a database. It can be used as a query engine or a data warehouse, and we excel at massive amounts of data, really big data. And I'm going to tell you about how about us and how we got into this project. Yeah. Okay. Just want to mention that what makes SQream special is that we've been designed and built for GPU analytics. We exist since 2010, when GPUs were used for gaming, basically. So we have a lot of patents in the way we leverage GPU efficiently to accommodate big data processing, whether it's analytics or AI/ML. A bit about GPU, probably some of you know the difference between GPU and CPU. GPU has thousands of cores, while CPUs has tens of them. They're a bit faster, but as it turned out, for analytics and big data processing, you need to do a lot of simple tasks, and you need to do them probably in parallel. And this is where GPU excels. If you, for instance, if you take a common solution that uses CPU, then in order to parallel process a lot of data, have to distribute data between workers. And then when you shift data around, you need to pay a lot of penalty for the I/O, for transferring the data between nodes or from memory back and forth. And GPU solves that by having the MPP happen within each node. So you don't need tens of clusters of tens of nodes in order to process some difficult query in a given time. You can just use the thousands of cores available for the GPU. Basically, this is what SQream does. We have a few patents in that area, and we manage and utilize the GPU very efficiently. We have a few patents related to that. And we operate both on GPU and CPU. Not everything requires GPU. For some cases, you even have to pay some penalty to work with the GPU. But in most cases, we aim to tackle with massive amounts of data. So that's your go-to. Okay, so how exactly is SQream doing it? Basically, we have a unique architecture. First of all, we decouple between storage and compute. So you can accelerate or scale both of them separately. For example, if you're I/O bound and it takes you a while to read the data, you can just scale your storage at another node. Or your queries are usually stuck on compute, and you can add another worker, another GPU. And the acceleration happens between each node in the GPU or between nodes. Also, we have trying to aim for zero bottlenecks architecture. So each node can check and read the entire storage. We don't do any segmentation in there. And the way we operate, we process segments of data, so we're not limited by memory capacity, whether it's the GPU memory or the CPU memory. And I think last but not least, maybe even the most important one, working with GPU isn't easy. Maybe if some of you tried Rapids, we'll talk about it a bit later. It's not easy to orchestrate the entire thing around it. And what's special in SQream is the entire optimization happens behind the curtains, and it doesn't require any manual intervention from the user. Just to give an example, think about the segment of data. We call them chunks, the chunk size that should fit the GPU. So SQream manages and resize the chunk to have the best fit with the best practice automatically. Other users that try Rapids with Spark have to do it manually, and this requires first knowing what you're doing, a lot of experience and a lot of engineering. I'm going to touch a bit about that later. A bit about SQream and where we're located. So as I mentioned, you can use SQream as your primary data warehouse. It leverages the benefits of the storage vendors, read every file format, and can, via JDBC, ODBC, and other connectors, interact with your favorite BI tool or your notebook. And didn't mention, we're a SQL database, ANSI compatible, I mean, almost. And also, you don't have to use SQream as your primary data warehouse. You can also just offload the most difficult, intense queries you have and data. You don't have to ingest the data. We can read it directly from streaming or other connectors, or directly from the database. By the way, we can also read on-premise and cloud, AWS, GCP, and others. So I promised you to talk about ML, so what it has to do with ML, and let me start by doing it now. So as SQream, we have our legacy, let's say, main product is our SQreamDB, our on-premise product, and we have a lot of big customers in the manufacturing business. Some of them are well-recognized names, and they manage over 30 terabyte, per one customer with SQream. So what we witnessed by interviewing the engineers and understanding what they're using SQream for, and trying to help them optimize the process, we saw the SQream is being used as a data preparation tool for the ML pipeline. So basically, they use SQream to extract data and do some data manipulation, cleaning, preparation, and other common functions, whether it's joining, filtering, aggregation, and other even Python functions. And afterwards, after those two phases were done, they shipped the data into other platforms, making a lot of copies and start training the models there, and which made them actually encounter some challenges. I'm going to touch that on the next slide. What we got from it is that now SQream can basically do the entire pipeline or take a bigger bite of this pipeline to deliver better value for our customers. And I'm going to explain a bit why it's a perfect match. So our customers basically shared with us that the challenges they are facing by working this way is first and foremost the computational costs. To train data models at scale, it requires giant clusters that has, by the way, big environmental impact, quite a lot of heating. And so first there was the computational cost. And in order to fit in memory limitations and other constraints, they had to compromise on the quality, or at least perform much more significant sampling processes that sometimes occurs in bias. So, for example, if you're training a network to distinguish between cats and dogs, and all the data you sampled as cats, all the cats were black, when you infer the network with a black dog, then probably it will guess it's a cat. So this is an example of the bias factor. So sometimes you sample out maybe just a bit anomaly, but this anomaly can later on affect your model significantly. So this is another challenge they faced. Also, privacy concerns. Once you start shifting the data around and creating copies, then you have to keep track of all of them and make sure you comply with all the regulations. And obviously, maybe last but not least, the engineering complexity. There's a lot of effort. If you want to speed up things, you have to work with GPU. And if you want to work with GPU, there's a lot of engineering required. And maintaining the pipeline going between platforms, that also was a significant challenge. Basically, all of those yielded a very lengthy, slow process of training. When I'm talking about training on large data sets. So before I introduce our solution, I want to let you guys know about Rapids by NVIDIA. So probably some of you already heard about it. So as I mentioned, NVIDIA a while ago, when we started working with them, they were just hardware for gaming, basically, with GPU. And now they're not only a hardware company, and in the recent years, they're also in the process of becoming a software company as well. So Rapids, basically, they released Rapids, which is basically an umbrella name for a few data processing, analytics, and AI libraries that are open source, and they make the GPUs, working with GPUs, more accessible by providing Python API and common algorithms that can run on GPU. The key libraries in there are CUDF, probably you're familiar, data frame that runs on GPU, CUML, the one we're using for the sake of this project. We have a lot of others, such as CUGraph and others. So this is very impressive. They made a giant contribution, basically, to the analytical world. Although Rapids do suffer from some challenges, what they do actually is they They make the working on GPU much more accessible by providing a Python API, but they suffer from a GPU RAM limitation. For example, if you have a GPU card with 6 gigs and you want to train 8 gigs of data, then you simply cannot. You get an error, and that makes you come up with some sophisticated ways to go around it, and requires a lot of engineering and knowing what you're doing. And also the entire orchestration around it is up to the user. So what usually people who use Rapids do, they use Spark. And as we all know, Spark, with all its benefits, has a lot of downfalls. And it's not made for GPU analytics. A lot of stuff you have to do manually, and there's a lot of configuration knobs within Spark, which make this process requires a lot of knowledge, skill, and a lot of engineering. So what we aim to do at SQream, leveraging the Rapid CDF and CML libraries, we aim to make this entire process significantly faster, having a united data platform for both analytics and ML and AI. We excel at large scale training, also the pre-processing. And I'm going to show you an example how it works later. The complexity is very, very easy to use and adaptive, both in SQL and Python. And this would hopefully yield a much shorter training cycle, which enables also data engineers to take a bigger chunk of the ML flow, not just the pre-processing, and basically bridge data silos and gaps between data engineers and data scientists. I know it's a big claim, but marketing PR. Also, a nice byfactor we got from it is we're doing better utilization over the GPU, since we offer more applications to run on GPU, such as the database and data preparation part, for the GPUs which suffer traditionally from a lower utilization. So how does the flow work? Let's take, for example, linear regression. The user can enter a simple command, whether it's in SQL or in Python. SQream triggers the entire process, fetches the data, whether it's from memory, from cloud, or from other databases, and streamline the entire process segment of data. The pre-processing part happens on the GPU, and we trigger Rapid's, for example, linear regression algorithm. And I wanted to emphasize that this is done with zero copy. The data is being read one time, uploaded to the GPU. SQream does what it does for the data preparation over the GPU. And then Rapids is being called natively, not via the Python syntax, rather than the underneath C library. And the data gets trained. In linear regressions, for instance, we train each chunk of data separately, calculate weighted average between the chunks. And for consolidation of the results, we're doing another few epochs of gradient descent. Then you end up with a model output. Also, I'll mention that we do support, not on Alpha, but we do support multiple GPUs training for much more data. Okay, so my favorite slide of the presentation. Basically, we do have a nice UI, but I much prefer showcase it on the regular CLI. So as you can see here, in a simple SQL statement, you can create your model, name it. It's a cluster object, that database cluster object. You can enter parameters such as which algorithm you choose and other hyperparameters for configuration. And in my opinion, the most interesting part, is the data that's being selected for the training. It doesn't have to be directly from the table. This is the query part. You can just enter whether it's joins, aggregation, other analytical, or some data pre-processing features in Python. Basically, this whole pipeline of ML is being streamlined within this process. And afterwards, you can apply the inference and predict. And also, here there's a query part. You don't have to do the inference on a specific table. You can just do it on whatever query you desire. Just preliminary result. This is linear regression on a single GPU. What's interesting here, in my opinion, is not just the time it takes us to execute, which is blazing fast by orders of magnitude versus common solutions. It's the fact that SQream scales linearly. When data gets larger, also the execution time, and we're not bounded by GPU RAM. Okay, in terms of roadmap, basically we're now at the alpha. We offer linear regression and DMLC's XGBoost are available. In the beta, we'll have much more features and algorithms, and we expected to hit GA by Q3. And thank you guys for listening. I'm Gil, and this is a link to my LinkedIn, and I'm happy to discuss and answer questions. Please hit me up on LinkedIn as well.
All right, Gil, thank you very much for this presentation. We do have a couple of questions. I hope you will be able to answer these. So if you can just elaborate a bit more about the performance optimization, how is that done? I know you touched that, but maybe give some information over there.
Yeah, sure. So we have a few layers. We have the data processing more than like the database layer, which does a lot of optimization itself, whether it's in the query planning or the execution. As I mentioned, SQream was built for GPU analytics, and also even in our query planning, we perform optimizations that will work better for GPU, and also obviously at runtime. And as far as the predictive AI, the ML, basically we streamline the entire process. And I want to emphasize that I think maybe it's the only solution right now that where the training starts, where the data resides over the GPU. So we have zero copy, which is much more significant. And we only just scratching I think the full potential of what we can do with this combination.
All right, thank you very much. Another one regarding replacing the existing data warehouse. So is that, do I need to replace my existing data warehouse with SQream product?
Yeah, so that's a great question. So the answer is no. I can go back to the giant architecture slide, but basically you either can, if you want to obviously be happy to replace your entire warehouse, but also you can just install SQream and offload your most critical and time-intensive queries. You don't even have to transfer the data. We can just read it directly from your storage or other databases or common tools.
Great, thank you very much. Anyone else? Other questions that you want to ask? So this is the time. If not, then you have a Gil LinkedIn profile over here, so you can scan it and contact with him directly. You also received an email from me, so if you have other questions or information that you want to get from us at SQream, I welcome you to email me or go to our website and fill up a form over there, and we'll be happy to meet you again in person or in our future webinars. Thank you very much for joining, and goodbye.